Time is such a familiar thing, isn't it? We start our stories with "once upon a time" and "this one time." We have invented an array of mechanisms to try and see how time passes. We've come up with ways to use the steady dripping of sand in a glass container, the consistent melting of candle wax, and the vibration of an atom. We think we know time so well, except we don't, not really. The way that we feel time passing differs from person to person. One factor that changes how you see time is whether you are stationary or not. Let's say that you were on a moving train and you were bouncing a ball, and a friend was on the platform looking at you through the opening in the train. As you passed through the station, your friend watched you bounce the ball. To you, the ball traveled in an up and down path, but your friend saw the ball travel in a sort of V path as the ball not only bounced up and down, but moved down the track. For you, the ball traveled a shorter distance than for your friend in the same amount of time. Using speed equals distance over time, then you find out that to your friend, the ball was moving faster. However, if you think about the ball as light bouncing, where the speed of light is constant, then you realize that time was different for your friend than it was for you. This is called time dilation. Basically, each person feels time pass at different rates. We see time as a river, and we are a leaf flowing with the current. We can't go back to the past, and we can't skip to the future. We are stuck in our state, even if it only lasts for an instant. However, we aren't really stuck. Our smoothly flowing river may actually be frozen, and we would be a deer walking on the ice. Physical time travel has always been in movies and television shows, from the longest-running sci-fi television show, Doctor Who, to Universal's famous movies, Back to the Future. Some films have a person traveling through time using a potion, some kind of small portable device that magically transports you to another time, or jumping through a rip in the fabric of time. However, time travel in this universe can be a little different. One method for traveling into the future involves using gravity. When the gravity is increased, you feel time going slower. One way to get an immense pressure of gravity, you can orbit around a black hole. This, of course, would be done with a space shuttle. This would make us travel through time slower than the time on Earth, making us basically fast forward through Earth's time. Traveling to the past is a little different. If you wanted to go from 2013 to 1913, we would have to find a wormhole. Theoretically, traveling through a wormhole is easy. You don't really need another vessel. It would be like walking through a tunnel. Wormholes are basically a shortcut that leads from one specific time to another. However, there was a problem with this theory. According to new calculations, wormholes would either be too small, some only 10 to the negative 33rd power centimeters in size, and some are too unstable. However, there are kinds of wormholes that may be usable. The way the size problem may be fixed is the fact that the universe is still expanding, meaning that some wormholes can be stretched, allowing more room for travel. There is another kind of time travel, chronesthesia. Chronesthesia is where the mind travels through time rather than the body. Chronesthesia can be defined as a hypothetical brain-mind ability or capacity acquired by humans through evolution that allows them to be constantly aware of the past and the future. In other words, looking back at your experiences is mental time travel. Chronesthesia is still a fairly new theory, and the mechanisms of mental time travel are not fully understood because of the level of obscurity and complexity when trying to measure if someone underwent mental time travel or not. However, studies have been conducted to map out areas of the brain that may be responsible for mental time travel. Many believe that mental time travel is a stronger idea when planning for the future than for re-experiencing past events. This makes sense because it is the present and the future, and not how the past is represented, that matter. Therefore, mental time travel involves both past and the future thinking. Time has layers. Time is not universal. Time varies from person to person. Time is changed by a variety of factors. Time is not how you pictured it a few minutes ago. Future, past, and present have always been ambiguous. We've never really known time, have we?